Welcome to the second installment of the Boston University Dialogues in Biological Anthropology, organized by Kay Brown. My name is Carel van Schaik. I'm at the Anthropology Institute of the University of Zürich. I study primate behavior in biology in order to better understand human evolution, and I'm today's moderator. The general purpose of these dialogues is to take an innovative conference-style approach to controversial issues in biological anthropology, which should, of course, help us to resolve these issues. The format is expressly not that of a debate, where points are scored at the expense of the opponent, which is increasingly also the way scientific controversies are covered in the media, but instead, it is one that brings together leading experts in the field willing to engage in a productive dialogue. And the BU community can also participate in this dialogue. If you follow this program on the webcast, you can email your question or put it on the wall of the Facebook page right on your screen. The theme tonight and tomorrow is evolution and altruism. If you had asked what is about a major question about human nature, say 50 years ago, people would talk about the irrepressible violence of humans. But in the last few decades, we have actually surprisingly learned about the other side of humans, of human nature, that is our altruistic side. And in fact, it's now thought largely to be responsible for our remarkable success as a species. And so a new scientific approach to the altruistic side of human nature is emerging from work in very distinct and in fact, unrelated disciplines. So primatologists, cognitive psychologists, and developmental psychologists are documenting the natural history of cooperation in humans and non-humans, and especially in our closest living relatives, the apes. And they try to identify through experiments the psychology of cooperation in these two lineages, and so document what is it that changed during human evolution. Behavioral ecologists and evolutionary biologists develop more general models for the evolution of altruistic behaviors, which, if you apply them to societies, help us to understand what you might call the superorganismic nature, say, of social insect societies and probably also human societies. And thirdly, behavioral economics is discovering that humans are not all rational egoists, as we were told that they were, but in fact, they may have an altruistic side as well. So these are very different fields with different approaches, different theories, different terminology, and that, of course, generates confusion and controversy. And we hope that to start sorting out these controversies in these dialogues. And right now, we have the first dialogue, and tomorrow at 4 p.m. we'll have the second dialogue, and followed by a roundtable at 5:30 p.m. Today's topic is the evolutionary aspects. And we have two speakers. We start with Dr. Herbert Gintis. He's an economist who's at the Santa Fe Institute, the Central European University Budapest, Hungary, and the University of Siena in Italy. Herb has made major contributions to the new behavioral economics approach to human behavior, which has done much to reveal our altruistic side, and so completely changed the way we think about humans. Herb, the floor is yours.
Thank you very much. It's a pleasure to be here and to talk to you about a cooperative species. That cooperative species is human beings. What I'm going to talk about is part of a book, or taken from a book called A Cooperative Species, which will be published about April next year by Princeton University Press. And my co-author is Samuel Bowles, who unfortunately is not with us tonight. This works. So this is an example of what our book might look like if we can get a permission from the ancient lithographer to use that print. So I want to propose two things about the nature of human cooperation. First, people cooperate not only out of self-interest, but also because they're concerned about the well-being of others. They try to uphold social norms, and they value behaving ethically for its own sake. People punish those who free ride on the cooperative behavior of others, even when they cannot expect to gain anything personally from it, other than the pleasure of hurting someone who has done wrong. That's the first proposition. Second, we came to have these moral sentiments, to use a phrase of Adam Smith, because our ancestors lived in environments in which groups of individuals who were predisposed to cooperate and uphold ethical norms tended to survive and expand relative to other groups. thereby proliferating those prosocial motivations, both culturally and genetically. Okay, now what do I mean by altruism? Well, cooperation can be mutualistic. An activity is mutualistic if it confers net benefits both to the actor and also to others. So I may act alongside of others because I benefit personally from it just as well as others. Cooperation may also impose net costs upon the individual, in which case we say that it is altruistic. In other words, something is altruistic. If I do something that's altruistic, it costs me personally, but it helps the group. By contrast to mutualistic cooperation, altruistic cooperation would not be undertaken by an individual whose motives were entirely self-regarding or self-interested, and thus did not take into account the effects of his actions on others or the welfare of the group. The evolution of cooperation that is mutualistic or involving only kin altruism means sacrifice on the behalf of close relatives, like your kin, your children, your family members. Mutualism and kin altruism are easily explained by traditional biological principles of natural selection because such behaviors help proliferate one's genes wherever they're located, whether they're in your body or the body of a kin. If it's mutualistic, it directly helps your genes because it helps you, including the genes that induce the helping behavior. So when you're altruistic, the gene that makes you or predisposes you to be altruistic is also being benefited by your altruistic acts. If you're involved in kin altruism or, okay, there you go. Now, there's a third form. It's not really a third form, but it's got a third name. Cooperation could also have evolved because of what's called reciprocal altruism, which is a form of mutualism in which I help you today in the expectation that you will help me at some future date when I am in need. Kin altruism, mutualism, and reciprocal altruism, which is really just long-run enlightened mutualism, are popular among biologists and economists alike. And they do, in fact, explain many forms of human cooperation. Many, many forms. Particularly those occurring among close kin or in very small groups of 2 or 3 people. These models fail to explain 2 facts about human cooperation. First, it takes place in large groups of non-kin. Humans cooperate with each other in large groups of often anonymous strangers, but certainly in large groups of people who have no direct genealogical kinship relation to one another. It occurs in interactions where there is no repetition. For instance, you ask someone directions on the street, you'll never see that person again. They don't know who you are, and they'll stop and spend energy and time to tell you how to get to your destination. That's a typical human behavior, which it depends on an altruistic motivation on the part of the other person. And even when there's complete anonymity, you'll never see that person again. They don't know who you are, and you don't know who they are. And therefore, you can have no reputational gains from behaving prosocially. You can't gain by it in some larger sense. Only a model in which humans have what we call social preferences that motivate them to participate and punish the transgressors of social norms can explain human cooperation in large groups of non-kin. Now, of course, the forms of cooperation and the behaviors that elicit punishment by peers differ from society to society, but the critical role of social preferences in sustaining altruistic cooperation is ubiquitous. We've never found a society in which people do not exhibit social preferences, including helping behaviors, altruistic giving, and also altruistic punishment, hurting those who seem to go against the social norms. Question is, how did this evolve? Well, there are 2 basic arguments here. The first one is that early modern humans inhabited the large mammal-rich African savanna and other environments in which cooperation in acquiring and sharing food yields substantial benefits at relatively low cost. So cooperation had high fitness benefits if it could be achieved. Second, humans have a very slow human life history. That is, babies mature very late and require a long period of nurturance. And this also made cooperation of non-kin in child-rearing beneficial, because while you're in childbearing age, you need help from others who are not of childbearing age. As a result, groups that fostered cooperation in hunting, child-rearing, punishing, prevailing against hostile neighbors, and sharing truthfully transmitted information, language, and communication, had significant advantages over other groups in which they did not hunt together, they did not rear together, they did not punish transgressors, they lied with equanimity, and they didn't fight together against hostile neighbors. Prosociality in general, and altruism in particular, were successful, we believe, for three reasons. First, human groups devised ways to protect their altruistic members from exploitation from the self-interested. The way they did that was by making sure that self-interested individuals, or individuals who did not act on behalf of society as a whole, were punished for doing so. Prominent among these is shunning, ostracism, and even execution of those who violate cooperative norms. Prominent also are the egalitarian practices that limit hierarchy and inequality, including the sharing of food and information within groups, and even relative approximate monogamy, in which virtually every man has a wife at some point or other. Also, these societies were very egalitarian in the sense that there were no big men in a hunter-gatherer society. There's no one who could control by coercion, simply because there were no means of coercion that were strong enough to do so. Second, humans adopted prolonged and elaborate systems of socialization that led individuals to internalize the norms that induce cooperation. Humans are the only species we know of that have a notion of internalized norms, that one is socialized to believe in act in certain ways. So that contributing to a common project and punishing defectors became objectives in their own right, not constraints. They became objectives, that is, people wanted to carry out these pro-social acts. They didn't carry them out only because they were afraid to get hurt if they don't. Allied with norm internalization are the social emotions such as shame, guilt, pride, and empathy that are at best rudimentary in other species. Third, between group competition for resources and survival was likely a decisive force in human evolutionary dynamics. Groups with many cooperative members tended to dominate and displace less cooperative groups, and thereby gain both through genetic and cultural selection. Throughout human history, group extinction, costly group dispersal, and ostracism, we think, have been powerful mechanisms supporting the evolution of human cooperation. The extraordinarily high stakes of intergroup competition and the contribution of altruistic cooperators to success in these contests meant that sacrifice on the behalf of others, extending beyond the immediate family and even to virtual strangers in one's group, could proliferate. The relationship between self-interest and moral sentiments has been illuminated in recent years by behavioral game theory. Unfortunately, I will not have the time to go through this now, and I would like to move to a final thought. This is a large jump from what I've said, but I think it actually accurately characterizes the political thrust and the social theory thrust of what I've been saying. This is a statement of the Roman Horace, who said, "Quid leges sine moribus vanae proficiunt," which means, of what use are laws not backed by morality? What we find in our work is that society works not because there are laws, but because people are committed to the working of society. The role of the laws is to prevent free riding and to make public exactly what the commitments are that we have to each other in society. Without morality, there can be no effective laws. Thank you.
Thank you very much, Herb. second speaker is Dr. Kern Reeve. He's at the Neurobiology and Behavior Department of Cornell University, and he's one of the leading figures in behavioral ecology. He, for instance, has helped us to predict variation in reproductive success among animals in societies, better known as reproductive skew. And Kern takes a very broad approach to social evolution. He will show you how you can use social insect models to understand the evolution of human cooperation in terms of the contribution to collective efforts. So basically, we're moving from social insects in one smooth movement to humans. Kern, please.
Thank you very much. So I'd like to talk about two ways that selfishness can result in the evolution of extreme altruism, as exhibited by the especially cooperative societies that are sometimes referred to as superorganisms. And by this I mean the advanced eusocial insects, which include ants, bees, and wasps, and termites, for example. These are the social insects, paper wasps, of the genus Displaces that I study. They were referred to as superorganisms by an entomologist named Emerson quite a few years ago, based on the analogy of a social insect colony with a multicellular organism, where the workers are the somatic cells that essentially don't reproduce and instead assist another individual, the queen, who's analogous to the gametes of a multicellular organism, to reproduce. Now, we can define superorganismness as a continuous variable broadly as in the following way. Let's take an individual perspective. Let's take an individual member of the group and ask what fraction of its energy or time budget, S, is it going to devote to increasing the total group output? We call this the group effort. The remaining portion, the selfish effort, being effort expended to try to increase that individual share of the pie. The share of the pie, the size of the pie, is increased by the group effort. Okay, so we would expect S to vary from 0 to 1, where S equals 1 would correspond to the case of something that very much resembles a classical multicellular organism, a true superorganism. But what we would really like to come up with is a theory that captures the entire variation from S from 0 to 1, both between species and variation across contexts within species. So the big question is, what are the evolutionary mechanisms that can yield a high S? Well, the first one I'm going to focus on is called policing against selfish effort. And policing itself is going to convey some selfish benefit. So it's one of the selfish mechanisms that actually props up cooperation. Here's the idea behind it. Now, it's been noted for a long time that many insect societies have high genetic relatedness, high kinship or genetic similarity among group individuals. But that doesn't automatically make them superorganismic, scoring high on the S variable. For example, in most insect societies, a focal worker here, the worker with the box here, can benefit by extracting resources from another worker and using those resources to reproduce itself. And in many insect societies, the worker also benefits by stealing resources from the queen that she would otherwise put to her reproductive use and use it to reproduce themselves. So there are at least two selfish avenues that can occur in these high relatedness social insect societies. The key to understanding why these two selfish pathways have been suppressed is given by policing. And that's the idea that it can benefit this worker here, the focal worker, to transfer resources from another worker to the queen, because this can increase its relatedness to the offspring that are produced. It's often more related to the offspring of the queen than the offspring of another worker. And the idea is that this policing could be a key to understanding why you get extreme levels of cooperation, S's close to 1. One of the best examples of this is worker policing in honeybees. It's observed that the queen produces virtually all of the males in the colony. Workers can lay male eggs. They can't lay female eggs. Unfertilized eggs in ants, bees, and wasps give rise to males. It's been shown experimentally that workers will eat any male-destined eggs laid by other workers. So there is something that resembles policing going on. And it's important to point out in this system, workers have a selfish incentive for producing the males in the colony because they're more closely related to their own sons by 1/2 than they are to the queen's sons, their brothers, which is only 1/4. The key is provided by looking at a worker's relatedness to the sons of other workers, that is, to their nephews, since other workers are typically full sisters or half sisters. And what you find is that this relatedness is a function of the number of male mates the mother queen has had. And the prediction is that if the number of effective mates by the mother queen is greater than 2, you have a situation in which workers are more closely related to the queen's sons through their brothers than they are to their nephews. So there should be selection for this policing of workers against egg laying by other workers. And the queen seems to be an important part of this puzzle because if you take her away, the colony becomes much less cooperative, the foraging rates go down, the workers enter into sort of an all-out tug of war, laying their eggs, in some cases multiple eggs in a given cell, at the expense of colony productivity. So we suddenly, by removing the queen, cause a transition to a low level of cooperation, a low level of S. So the queen is important somehow. So the idea is that worker policing funnels reproduction to the queen, creates an overlap of genetic interest, and that increases the level of cooperation in the colony. But there are a couple of problems with this idea. For one question is, how do we explain why the queen got to lay most of the eggs in the first place? Why was she, in effect, given resources by the other workers? Secondly, and this is a potentially big problem, policing itself is costly. It takes time and energy that could be devoted to other activities, such as guarding the colony or collecting resources for the queen. So it potentially could reduce colony output. So does policing really have the net effect of increasing the degree of superorganismness? So it's hard to answer this question with the existing models because policing and the selfishness are not allowed, theoretically, to co-evolve with each other. I'm going to tell you about some of our efforts to model their co-evolution mathematically using a game theory approach. Now let's take the first problem. Why do workers initially transfer their collected resources? They do most of the work in the colony, bringing in food and water, etc. Why do they initially transfer these to the queen for reproduction? We're going to use a game theory model called the tug-of-war approach to make sense of this. In a tug-of-war, let's say we have 2 workers here. The big worker here is our focal worker. They've each collected some bit of resource, but they're going to use part of this resource, part of this energy, to devote to a tug-of-war over possession of the joint resource, the total amount of resource that both have collected. X here is the fraction of this individual's resource that it's going to devote to the tug-of-war in an attempt to increase its share of the total amount of resource the 2 collected. And the idea is that the more that they invest in selfish competition, the less is the total amount of resources, an optimal trade-off. And what game theory is interested in is what is their optimal relative selfish efforts, given that your selfish effort determines your fraction of the total resource going down, the more is deducted in selfish effort. So let's imagine we have a group of workers and a queen who hasn't collected anything. The workers have collected something. A worker has a choice of entering into this tug-of-war, an in-person, mutual, all-out tug-of-war along the lines that I just described, all right? Or it has the option of just simply opting out of that tug-of-war and giving its resource directly to the queen. Now, the key parameters in this model are the worker's relatedness to itself, really to its own offspring, its relatedness to another worker, and its relatedness to the queen, R sub Q. What you can show is that the giving option is theoretically favored over taking place in the all-out tug-of-war as long as the focal worker's relatedness to the queen exceeds that to the other focal workers. Under this condition, RQ greater than RW, it pays this worker and all the workers to simply give the resources to the queen. So great. We go to the second stage. We have a queen that's sitting with all these resources it's received from the other workers, but there's a problem. Now the workers, because they're still more closely related to their own offspring than to their own sons and to the queen's sons, all have a temptation and a genetic incentive for taking these resources back from the queen and using them for their own personal reproduction. So what stops this? Well, this is where the policing comes in. What if the workers, in the process of extracting resources from the queen, used some fraction of it to police against other workers and force other workers to return some of their stolen resource back to the queen? Of course, this will elicit resistance behavior by the focal worker. So you have policing and resistance potentially going on. And of course, this is going to go on involving all of the workers. What evolves in this circumstance? So here the tug of war has the following structure. This is an individual worker's energy budget. It's going to devote some fraction Z to this selfish resistance effort, that is, in an attempt to resist policing efforts by other workers who are trying to force them to give their stolen resource back to the queen. But there's also going to be policing effort, where the focal worker polices against other workers, forcing them to return resources to the queen. What's remaining from this is the contested resource, some of which will go to the focal worker, some of which will be forced back to the queen. And what we want to know from game theory is what's going to be the equilibrium result. Well, it's easy to write down expressions for how much the focal worker gets. I won't bore you with the math. You can look at this later if you have time to look at it on the website. We can calculate the amount of reproduction and resources going to the other workers and to the queen, and combine all of this in an inclusive fitness expression and ask, to solve the model, what are the levels of policing and resistance that maximizes the focal worker's inclusive fitness, given that the other workers are trying to do exactly the same thing? We can get some solutions that at first may look somewhat complex to you, but here's really the key payoff. In this model, the ratio of selfishness, that is the resistance to the policing, is equal to this following simple ratio of the differences between two relatedness. The numerator, R sub S minus R sub Q, is basically the genetic incentive or benefit to the worker for taking resources from the queen. The greater this difference, the greater the genetic incentive. Whereas the denominator, this difference, is the genetic incentive for returning resources to the queen and away from another worker. Here's the key payoff. If you look at the space of outcomes where you calculate the total amount of resistance effort and policing effort in the system, right? So look at it from an individual worker's point of view. How much of its energy budget, what fraction is it going to put into both resistance and policing? You see that there are a couple of cases, couple of situations where the relatedness to other workers and relatedness to the queen lead to very low levels of total destruction arising from this tug of war. That is, to a high level of superorganismness. Over here in this corner, we have a low incentive for selfishness. That means there's very little policing required. And so the sum of the policing and the selfishness is very low. We get something that's very going to yield a very high level of cooperation, a high S on our superorganism continuum. At the other extreme over here on R sub Q, the relatedness to the queen, approaching the relatedness to the other workers, we have a low incentive for policing, high, and therefore very little incentive for resistance. And so we again have a very low total amount of conflict in the system. All right, now the key comparison is this. What is that total conflict, the total amount of resistance plus policing when the queen is present versus when the queen is absent? Or we can calculate the difference without the queen minus with the queen. In this surface here, for all the possible values of the relatedness to workers and the relatedness to the queen, you'll see that this surface always sits above 0, which means that having a queen in the system, regardless of the value of R sub W and R sub Q, always lowers the potential conflict in the system. So there's something about policing favoring the transfer of resources to a queen, right? An individual to which the workers are more closely related than they are to each other, that greatly reduces within group conflict. And in fact, I would like to propose that this is a general principle of cooperation promotion among competing units. I don't have time to get into it here, but I think it can explain why the early differentiating cells in development tend to be the primordial germ cells. Turns out theoretically all the cells in the organism should agree via the very same policing model that it's the primordial germ cells that should do most of the reproducing, because it turns out they'll have a higher mean relatedness to it than they will to cells in other tissues. Don't have time to develop that argument. What I'd like to do is focus on, to make a transition to the subject we addressed earlier, how could this model of policing potentially apply to human groups? We're going to focus on this corner down here, where R to W and R sub Q are very close to each other, which is a situation where most of the social members reproduce with low amounts of selfishness and policing. Well, there's no queen in a human society, so how could this queen policing model possibly apply? Well, suppose that you have a group of N unrelated organisms potentially competing for resources, okay? R sub S is 1, R sub W is 0, they're unrelated to each other, but there's no queen. However, suppose the policing ensures that everybody devotes at least some of their resources into a common pot, which is then dispensed fairly. That is, the pot returns a return like investing in a related queen. But the relatedness to the queen here is just equal to the fraction of a pot that an individual is going to get. The effective relatedness is 1 over N, where N is the group size. That means we have the policing inequality met. Exactly the same model that applies to honeybees can apply to this system and potentially explain why there are low levels of conflict. And in fact, the theory shows that in this community pot policing, you get much lower levels of conflict, a higher progression to the higher end of the superorganism continuum than you have in the case where there's no fair pot, where there's an all-out pure tug of war. Finally, I just want to emphasize that there are evolutionary mechanisms that we're now approaching that we're now understanding in the social insects that involve a second kind of selfishness that promote cooperation, just as we're finding in primates and humans, namely intergroup competition. The idea is very simple and was already articulated by Herb. If you have two-level tug of war, if there's a tug of war going on within the group and it's too nasty, that might reduce the group's ability to succeed in a tug of war between groups. So that can lead to very high levels of superorganismness if there are a sufficient number of competing groups, as shown in this graph here. Number of competing groups is this way, even when the relatedness is relatively low. And believe it or not, we're beginning to get evidence that this occurs even in the social insects. In a field experimental study in my paper WAS, if you decrease the distance between neighboring colonies, bringing into more intense competition for forage and for space, you find that both colonies exhibit an experimental increase in the per capita foraging rate. They spend more time on their nest active, and they invest more in defensive behavior. In other words, they become more cooperative, presumably because they're in competition with another group. So here's a case where experimentally increasing the degree of between group competition increases the degree of within group cooperation. So in sum, seem to be at least two selfish routes to superorganisms and social insect societies, policing to a third party, something that acts like a queen, and intense intergroup competition. I think it's becoming obvious in part from our discussions with each other that we're all converging on a similar set of principles to explain high levels of cooperation in a variety of organisms, humans, social insects, and potentially extending to levels of biological organization below the level of an individual. Thank you.
Thank you very much, Kern. So great. We have basically heard two presentations, one about what you might say how to characterize humans, and we've heard that humans have these prosocial social preferences in which they are basically supporting each other, and we've heard some ideas about why that would have evolved. And the second talk was really about what conditions can make individuals effectively cooperate, not wasting any effort, the superorganismness, not wasting any effort on individuals' activities that detract from the collective effort, and coming to rather surprisingly similar conclusions, right? It's the degree to which you need to share within a group to get that collective effort going, and the degree to which competition with other groups might actually force you into that direction. We have already received a couple of questions that I'm now going to relate to our speakers. You still have an opportunity to send some more by email or by the Facebook page. Let me start with question number 1, where sort of elaborating on this theme that both speakers have stressed the importance of between group competition which is linked to resource distribution and densities and so on. But there's also what the questioner calls endogenous factors, and that has been stressed a lot in the evolution of insect societies. What you might call, I like to call it real estate. So big structures that are needed. And one question is, what's the relationship between this big real estate and between group competition? Is there some evidence that we see coevolution between these two? Can you have one without the other? Can one drive you into the direction of the other? I guess Kern would like to go first, and maybe if Herb has anything to add to that, we can...
Oh, sure. Well, I think the current idea is that, in fact, there's some empirical evidence for this already coming in. In the social insects, you tend to get higher levels of intergroup competition when the resources are more patchily distributed. That creates a selection pressure for settling in a patch and having other group members around you to help defend it against other potential groups. Of course, that might be important early in the origins of cooperation itself, the group living itself in the social insects. But as they then settle in a patch and begin to develop nest architectures, tunnel systems, elaborate termite mounds in the case of termites and so on, they actually are increasing the scope for intergroup competition because this increases the payoff for trying to steal these structures and make use of them by other groups. So it actually ratchets up the degree of within-group competition so that the degree of cooperation ever spirals upwards. So
becoming more and more of a superorganism.
That's right. They'll be mutually reinforcing processes.
Would anybody like to speculate on whether something similar... What's the equivalent of the nest in humans? Is there any, or in other words, can we have the same process without any nest sites and real estate and architecture?
Well, I think we do. This is somewhat speculative, but if you look at the history of weather during the evolution of humans, say go back 150,000 years, there was 100,000 years of extremely variable weather. Every 1,000 years it was different. This led to increased brain size of basically all primates and even mammals because they had to deal facultatively with very different conditions. So they're fighting against nature. And a lot of the evolution of sociality in humans, I would argue, is really being able to cooperate in those conditions where if you do not cooperate, you will disband. Mm-hmm. And your future will be very dim. This intergroup competition, I think, is more plausible in the past 50,000 years, mm-hmm. where if you look at the temperature record, it's become much nicer, much more calm. The rate of vegetation increased. The distribution of the temperatures across time became very involatile. They settled down, and humans began to expand in density and therefore create culture. But there's still at that point probably intergroup competition became more important. Who's going to control the surplus that's generated by the temperatures? So it probably did, but I this is just speculation because in all times, I would say, humans cooperate because they have to deal with their prey, which means the animals that prey on them and the organisms that viruses and bacteria that kill them off, and they have to cooperate to deal with other humans. And between the two, we can understand why we've been so successful. And the percentage of which is probably, difficult to determine.
Sure. Well, this is actually a wonderful segue into the next question that I have on my list here. And it's asking a question about humans compared to chimpanzees, because I think I know what your answer is going to be, but I think it's mainly for you, Herb. The questioner asks, saying, look, chimpanzees have some serious between-group conflict. They kill each other once in a while. They collaborate in that. It has fitness consequences. And in fact, people have estimated what's known as the FST, so the genetic differentiation between chimpanzee groups is similar or even higher than that of humans living in traditional societies. So chimpanzees seem to have everything going for them in the same direction, and yet they don't have this human kind of psychology that we've ascribed partly to between-group competition in humans. So what is it about the chimpanzees that's holding them back, as it were?
Well, I think there are two main differences. One is chimpanzees do fight with each other, but they don't fight group against group. If a small group of chimpanzees from one troop encounters a lone chimp, they will attack it. But the idea of like 10 chimps on one side or a troop of chimps attacking another troop of chimps and destroying it, that is not the way chimps do things. They only fight they only fight when they have a numerical majority by far, and usually it's 3 or 4 against 1. Second, humans did something that chimps didn't do, which is they developed the ability to use projectile weapons in order to catch prey. Chimps cannot do that at all. The fact that you have projectile weapons and poison darts and that you can kill at distance and you can kill easily someone who's asleep means you can't have the hierarchical structure of a chimpanzee society with an alpha male. With an alpha male chimp, if you want to fight him, you have to wake him up. You can hit him, but you can't kill him. And then the big man wins. Humans were quite different. In order to have cooperation in humans, the leaders had to persuade everyone that they were right. They had to use persuasive means, not coercive means. And this created a very egalitarian sharing situation, which chimpanzees never had. So, we really had a form of cooperation much more egalitarian, decentralized, and effective. Effective because humans were able to use their means of destruction, that is, weapons, to much greater extent than chimpanzees. So cooperation was much more useful to us. Also, chimpanzees are basically foragers. They hunt, but their hunting is often thought to be symbolic. Mm-hmm. They do love to eat monkeys, but they don't really need them for sustenance. Humans had to do what they did in order to deal with large prey.
Kern, would you like to add something?
I just want to add something to that. There is group warfare, for example, in ants. There are territorial tournaments that are well described. But I want to make it clear that you could also have more subtle intergroup competition, even though there's no overt fighting. We know there are at least two kinds of competition: interference competition and exploitative competition. The interference is direct physical encounters over a disputed resource. But exploitative competition is just simply trying to use up a limited resource faster than another colony does. For example, if you're a social insect, sending out more foragers and having them forage more efficiently in a shorter amount of time and so on, can give your group a competitive advantage over a rival group that's after the same resource. So even though you don't see overt fighting, that doesn't mean that intergroup competition is not present. Sure. It could be actually quite potent. And we're going to be looking for that in cases where we have extremely high levels of cooperation, right, even among the advanced social insects.
Right.
Can I add a point?
Sure, of course.
That is all true, but there is something like Lanchester's law, yeah, which says that there are increasing returns to cooperation in fighting against another group. If it just depends on your superior ability to forage, it's not clear that there's any gain to cooperation. The gain to cooperation is by coordinating your behaviors when you're involved in a physical battle with another group. At least that's, I would say that adds to that considerably.
Right.
You probably want to respond.
Well, yeah. What can happen, though, is you're probably going to be a more efficient forager, that is, collect more forage per unit time, the less time you spend fighting over who's going to lay which eggs in the colony.
Yeah. All right. Of course, we could say a few more things about what is then subtly different between chimps and humans, or what is actually similar between chimps and hunter-gatherers. For instance, hunter-gatherers are in fact known to have hostile between group relations that are rather similar to what chimps are doing to each other. But I think for now, the interdependence seems to be a really important factor that the chimps are missing, that you've described for everything before 50,000 years. That might also be an additional answer to the second question. Let's move on to the next one. And it sort of brings up the very thorny issue of group selection. Basically, both speakers have been talking about the role of intergroup, or in other words, between group antagonism and competition. And that raises the whole notion of success at the group level versus the individual level. And in fact, two questions are about this. What exactly is what's for instance, if you look at the first speaker and the second speaker, are they invoking group selection models? Are they invoking different kinds of models? Is a multi-level tug-of-war model a group selection model, yes or no? And there's a lot of terminological confusion, partly because of these different fields using different terminologies. And of course, within evolutionary biology, at the moment, again, raging a controversy about the role of group selection. And so I think our speakers may want to comment on this issue because it is an issue that doesn't go away. First?
Group selection is a very contentious issue, but I think that most of the heat is not accompanied by light. That is, people seem to disagree, but no one can really say what it is exactly they're disagreeing about. From a purely population biology point of view, if you have a group selection model, you can equally describe it as an individual selection model. The accounting goes over perfectly. You can even describe it as a gene selection model. Any of those three is okay, as long as you get the accounting relationships okay. I think the real issue is this. Does group composition matter? In other words, are the fitnesses that you put into your equations, where you find out who's doing better than whom, are those fitnesses dependent on the structure of the group, or are they kind of individual level or gene level constructions? And it's obvious to me that in the things that I was talking about, or that Professor Reeve was talking about, we're talking about social constructions. This is called sociobiology, where we're talking about the social structure of different species, and therefore the fitnesses of the individuals in those species are functions of the social structure. So it's not that group selection means there's some supra-level dynamic that can't be captured at the individual level. It is captured at the individual level. In order for a behavior to evolve, it must have, on the population level, higher fitness than what it displaces. How that happens depends on the structure of social interaction. But if you define altruism as population level sacrifice, then there cannot be any altruism. So we always define altruism at the group level. That is, you're hurting yourself to help other group members. But in the large, this has to help expand the genes that promote the behavior you're talking about. So for instance, without assortative interactions, if you have groups and they're totally random in terms of kinship, you cannot have altruism. You have to have processes that lead individuals to have offspring that are more like themselves stay in that group. And if you do not have that, you cannot have altruistic interactions evolve. So in that sense, the individual fitness thinkers are correct. There's no mystical group selection process, because what's selected is individuals who reproduce and ultimately genes that reproduce. But to conclude, the fitness coefficients that go into the equations that decide who's going to win, who's going to lose, are determined by social structural macro phenomena, such as the shape of a beehive, and or in humans, the social relations and culture of human hunter-gatherer societies.
I'll just reinforce that very briefly, because this point is so overwhelmingly important. There continues to be a lot of ink spilled on this controversy. It's basically a waste of time, wastage in a tug of war, leading to a tragedy of the commons from my viewpoint. And the point is this: every individual, broad sense individual selection model and a group selection model can be translated from one to the other. Now, that's not to say there aren't heuristic advantages to using one kind of approach versus another, depending on your problem. If, for example, you're interested in interactions between groups and how group composition can affect fitness, you need to be able to partition selection into between group and within group components. And the group selection models, or what's sometimes called the levels of selection approach, is uniquely set up to do that. So that's why we use it so often for these kinds of questions of cooperation.
Excellent. Well, that should put that matter to rest, although I doubt whether it will forever. But that's an excellent expose. I have one more question here about policing. and I guess that's more for Kern here. The question is whether do all animals, all members of the colony need to police equally, or could you sort of farm it out to specialized policemen who are taking care of it, like specialized punishers, as it were, in the human sense, who take care of this, and basically the rest gets on with their own job?
Wow, that's a great question. I might invite the questioner to join my lab, because this is exactly what Tom Seeley and I are investigating in the honeybee case. Are all the workers equally likely to engage in policing behavior, or is there a special subcaste? There's no theoretical reason why there can't be, and it's easy to develop frequency-dependent selection models where you have certain individuals specializing in policing and others not. But we don't know the answer to that in nature, and in any of the social insect societies in which policing's been described, not just honeybees, but yellow jackets and so on. That's a question that's very much a topic of empirical inquiry right now.
Now, maybe I can sort of slightly rephrase the question.
It's fine the way it is.
About humans.
Yeah.
What do we see in humans?
In humans, what we see is that humans have an innate, I won't say it's a predisposition to punish those that they don't like, at a cost to themselves. This is a form of altruism, altruistic punishment, it's called. In fact, it's so strong in humans that it has to be curbed by society. Almost every society we know punishes people who do too much punishing. They're not allowed to do it yourself. You're not allowed to engage in individual level punishment beyond a certain amount. And in even small-scale societies like hunter-gatherer societies that we know about, the act of punishing is decided collectively by the group and is delegated to a subset of the group, usually with the permission of the kin of the person who's going to be punished. So the idea of this individual level all going on all over the place, that's just not human, because humans overdo it. They have to be basically forced into a social level of punishment. And there is no caste, but I'm sure that there are personality types that are prone to it. If you go to a particular society, some people are really happy about criticizing everybody's little mistakes and correcting them, and other people are not like that at all. We have what we call behavioral heterogeneity in this respect. And this is very, I think, typical of human society. Obviously, there's no caste of punishers in humans.
Although one would, I'm sure it depends on the type of society that has developed. I think among hunter-gatherers, it's, you wouldn't speak of policemen, but once you have states, you get policemen, and somewhere in the big man, it's to some intermediate cases. So I think that there is an interesting question that relates to the insect societies. What are the conditions that lead to the emergence of some specialized punishers?
Well, in humans, it's very simple. Until you get sedentary agriculture or trade, where there are means of production and wealth other than what can be carried around on your back, you can't have specialized anything except by cooperation. You can't have specialized coercion. Until you get states that have money or some form of rewarding people for specialized division of labor activities, they don't occur. When they do occur, then I would not say that there's any specialized caste. Being a policeman is just like anything else. It's a job.
It's a job.
Well, in honeybees, there are some good reasons to expect that there might be, if not subcasts, stages of development of workers that you'd expect to find it. We know in honeybees there's a pattern to development that's called temporal polyethism, where workers progress from initially serving in brood care and assisting the queen to becoming foragers later in life. My guess is it's the earlier workers, the younger workers who assist in brood care, that are best positioned to detect cheating going on in the cells where other workers are trying to lay eggs. They were the ones I would expect to patrol the cells and detect worker-laid male eggs and remove them and allow the queen to replace them.
So this is actually a really important topic, the whole punishment, because again, it's also an active issue among hunter-gatherer studies, and where some people argue there is no punishment, there's just shunning, but I'm sure if you do the math, you can turn shunning into punishment, so it has functionally the same effect. There's two more questions. We've got a few more minutes. One question is about the current controversy around kin selection, that kin selection doesn't seem to play the role that theoreticians have said it plays, and I would like to hear the panel's opinion on this.
Well, it depends on what you mean by kin selection. All of the models I talked about were in the framework of kin selection, and that you have to take the relatedness of the affected parties into account to predict what's going to evolve. In other words, the genetic interests are going to be of an individual are going to depend on their coefficients of genetic relatedness to the other individuals that are affected by their actions. Mm-hmm. So it's very much a component of my models, even though my models, the models that I focused on, never claim that high relatedness, for example, itself is sufficient to guarantee cooperation. There has to be this special policing mechanism, for example, in the first case that I discussed, a policing mechanism that's favored, but how you determine whether it's favored is by using concepts from kin selection theory. So it depends on how simple-minded or simplistic the kin selection theory is that you're imagining. I think it has to be a part of any kind of theory of policing and cooperation in which you have interactions among relatives. And as I argued in the second part of my talk, the policing mechanism, even when it involves non-relatives, still the relatednesses to your own offspring
Sure.
Are important, and that brings it, in many people's view, under the rubric of kin selection theory.
So a short summary would be, yeah, of course, go ahead, yeah.
There are two terms that biologists have used. One's called inclusive fitness, yes, and one is called kin selection. Now, it has come to, those two terms have come to be used interchangeably by population biologists. Even though when we, in everyday life, if we say kin, we don't mean someone who has some, statistical relationship to us, of some correlation coefficient. We mean kin, our children, our nephews, our grandfathers. Kin selection of that form is not at the heart of what all of us, any of us mean right by inclusive fitness or associative relations. As I said, you have to have people who share your genes, who you help if it hurts you. That's called associative interactions. And that can be called, it's certainly inclusive fitness. If you want, you can even call it kin selection. You just don't know who the hell they are. Excuse me. Oh, jeez. You don't know who the heck they are. The terms have changed over time. Now, I think the really important thing here is kin selection requires that you have numbers that you use to decide who's selected. Those numbers can be determined by higher level social structures, mm-hmm, like beehives or anthills or human societies. The fact that you say kin selection or inclusive fitness doesn't mean that society is irrelevant or culture is irrelevant or the structure of social interaction is not important. That's kin selection is just an accounting relationship.
But a valid one. And the recent attack on kin selection as an explanatory device is probably suggesting that it's not really well placed. There's tons of empirical evidence in favor of it. And I mean, all these models that tell us a lot about social behavior of animals that are built on it and give us the right predictions, they probably do something right. I guess the reason for the confusion is that some people would argue, and correctly, that kin selection alone is not going to help us understand the evolution of eusociality, because, for instance, you need a lot of additional models and interactions, and basically need ecology and economics, as it were, of the system to understand the evolution of these systems. And then, in other words, you need more than just kin selection, but you certainly do need kin selection. You cannot do without it. We have a little bit of time left, and there was one question about the role of reputation. I guess that's for, so I don't have time to elaborate, but maybe you can briefly talk about reputation.
Okay. Humans relate to each other over time. People see each other again and again, husband and wives and kids. You go to work, people in your community. You can develop reputations that will help you in the future. And the question is, when people are nice, when people behave pro-socially, is it because they want to just get a good reputation of being treated well by others? Are they selfish and nice because it could help their reputation? I don't have the time for a full answer, but we can actually take people in the laboratory where there's anonymity, one-shots where there's no chance for anyone to develop a reputation, and they still behave in prosocial ways. Just as the person who stopped on the street to give me directions at a cost to herself without any notion that in the future that person would benefit from it in any way.
So in other words, most people don't consciously represent reputation as a motive for their actions, even though it may be a function. I guess that's it for tonight. We're sort of out of time. Don't remember that we are tomorrow back at 4 o'clock, with our second dialogue, and then we're going to largely talk about the altruistic behavior of humans and mainly chimpanzees, and the ontogeny of these behaviors, and how whether or not these behaviors are psychologically regulated in the same way or in different ways. So stay tuned for that, and thank you very much to Kern and Herb for great presentations, and you for attending. Thank you.